Hi everybody, this is the video for the third Stata session that we had when we were looking at inequality and returns to education, changes therein over time. So just a quick review of what we actually did in the class. I'm not sure if everybody was able to make it. So I got my data set open here, the CPS data. This is a subsample of the data that Matthias, who gave our guest lecture, actually uses. It's a smaller data set than he has, but it's just a random sample of what he has. And so there's lots of information here. We have our variables over here. So we have people's gender, people's age, levels of education, the year, the real wage, and a couple of dummies here that categorize race. So what we're interested in looking at the wage distribution. Now it's important to note that what we have here is a different structure of data than we've had in the past. Before we were just using cross sections. Now we have a repeated cross section. So if you just go ahead and tab year, so tabulate the year, you can see here we have 1990 up to 2012, and we have about between 5,000 and 6,000 observations in each year. Okay, so we have 6,000 people in 1990, we have 5,850 people in 1991, and so on and so forth up to 2012. Now this isn't a panel, these aren't the same people, these are different people, but it says each year it's a random sample drawn from the same population of workers in the United States. Now this creates opportunities to do something that we haven't been able to do yet, which is look at how things have changed over time. Whereas if we just had, say, 1990, we could only look at things having to do with what was going on in 1990. Now we can look at changes over time, which can be, I don't know, interesting. So the first thing we want to do is plot the distribution. We can do that by using a histogram. Just open my do file here. So this is usually a good way to just get a sense of what our data look like. So we're just going to use this command hist or histogram real wage if year equals 2012. Now this condition is saying Stata, do this command for me, draw a histogram of the real wage, but only for the year 2012. Then we hit enter and look at that lovely little histogram there. So this looks like just about every other wage distribution that's ever been. And we have lots of data around the sort of mean median here. The mean, of course, will be higher than the median since we have a long upper tail. And then we have very few people with very low wages, and we have fewer and fewer people with high wages as we go up and up and up. So we still have, you can just see there's just a little tiny bit of a bar there. So there are some people with these very high, so these are hourly wages, very high wages, but very few people. So skewed distribution, most of the data is right there in the middle. And when we talk about inequality, what we're talking about is summarizing the information contained in this distribution. There's all sorts of different summaries. So the mean is essentially a summary of the information contained in that distribution. But inequality is a different thing that we're trying to measure. So how is that distributed? What does that distribution look like? Not necessarily where is it located, which is what the mean would tell us. So we're going to look at a couple measures of that and then try to look at why that might be. So the next thing we're going to do then is we can look at this is a visual representation of the distribution. We can close this and we can look at a numerical representation of the data where we summarize real wage. And let's also say if year equals 2012, and then comma D. This is something I did not make clear on the worksheet and should have. This comma D or comma detail will give us more information about the distribution than the standard summarize command. So here we have the histogram is basically this information represented visually. So here it's showing us these different percentiles for the distribution. These are the 4 smallest values. These are the 4 largest values in the distribution. We have observations, and we have the mean here and standard deviation. Okay. Now, the next thing that we want to do here is calculate the 90th, 50th, and 10th percentile of the wages for the year 1997 and for 2012. We've already done that for 2012, right? We have the 10th percentile, we have the 50th percentile, the median, and we have the 90th percentile here. All right. And using those, we can construct the ratios that Matthias was talking about. We can construct the 90-50 ratio, which is just 37.69 divided by 15.89. That's the 90-50 ratio. The 90-10 would be 37.69 divided by 7.83, and so the 50-10 would be 15 divided by 7.833. Right? But that's just for 2012. And we can go here for, let's say, 1997, just the year we chose. and we can construct those same ratios. Okay, so I'm going to do this just so we can see them next to each other. Okay, so here I've done it just using Stata to do it for me. We have a 90-10 or 50-10 ratio for, this is for 1997, and this is for 2012. So just looking at these 2 points, remember we're just looking at 2 points in time. We have all this data for all these years, but we're just looking at 2 points in time. And we can see, well, what's happened to the distribution? Well, it looks as though the top of the distribution has started to pull away. So here we have a 90-10 ratio of 4.81 in 2012. In 1997, that was 4.22. So the ratio of the income at the 90th percentile versus the 10th is larger than the ratio in 2012 than the ratio in 1997. Right? So the ratio of the 90th percentile to the 10th percentile has increased between 97 and 2012. The 50-10, however, has also increased, but not by nearly as much. Not by nearly as much. It's gone from 1.98 in 1997 to 2.2 in 2012. So what this, just looking at these 2 points in time, it suggests, well, the top of the distribution seems to be pulling away. When doing this sort of analysis, considering changes over time, we don't really like to look at just 2 points in time, because those 2 points might be outliers, right? Those samples might be, we have random sample variation. It might be that one or both of those years are funny somehow, or there's some sort of variation that's producing this result. It might be, this isn't actually as big as it should be. This is too big in some sense, or this is too small in some sense. But what we really want to do is be able to look at this for every year and then consider the trend. There's going to be variation from one year to the next, but we want to know over time in general, where have things been sort of trending? What directions have things been trending? Okay. So from this, we would conclude that it seems like inequality has been increasing, at least at the top of the distribution has been pulling away. The middle, there's relative to the bottom, hasn't changed very much. But we want to look at all the years taken together. So what this suggests is top income earners are earning more relative to middle income earners between these 2 years. The next thing we want to look at is calculate and report the fraction of workers with a university degree in 1997 and in 2012. So we can do this a couple of ways. First, we can tabulate, let's see what our education variable looks like. So tab educ. So we have this qualitative variable. Okay. These we could probably exclude, but it's so small we won't worry about it. Probably just means it's missing. So if somebody didn't remember, maybe they're very old, they didn't remember something. We have these 4 categories. So high school dropout, high school grad, some college or associate's degree, and college graduate or higher. Okay. What we are interested in is this top group. So the proportion that have a university degree or higher. So we could do this 2 ways. One, we could create a dummy, or we could just do tab educ for the 2 different years. But what we are going to do is create a dummy that is equal to 1. So this is a little shortcut. So if we're going to generate a new variable called unigrad, and that variable is going to be equal to educ equal 4. This is a shortcut way of creating a dummy. Before, in the past, we've done it where we said generate a new variable that's equal to 1 if this condition is true, and then you recoded the missings into zeros. This is just a shortcut. In Stata, there's lots of different ways, many different paths to arrive at the same outcome, and so shortcuts are always really useful. So this is a nice shortcut for creating a dummy. So we're just going to create a dummy called unigrad, and then we can just say, we can use summarize or tab, but let's say tab unigrad if year equals 1997, and then we can just click on our command, get it back, and change that to 2012. And what do we see? Well, in 1997, 27.53% of the sample were university graduates or higher, so bachelor's degree or higher. If we move to 2012, so just a short 15 years later, and that's increased to 34.78% of the sample have graduated from university. So we have just over a quarter to just over a third of people are graduating from university. Change between 1997 and 2012. That seems like a lot more. So what this is telling us is there's been this big increase in the supply of university graduates. Right? So now we have 2 bits of information that tell us something about the world and how the world has changed. One, when we look at these percentile ratios, is that the 90th percentile relative to the middle has increased over time. So top wage earners are earning more than middle income earners. And we see that the ratio of the share of people going to university and graduating has increased as well. And these 2 things are happening at the same time. Okay. So we have 2 bits of information. That our initial thoughts could be, oh well, if the supply of university graduates was increasing, we might expect wages for university graduates to decrease, holding everything else constant. We know from previous studies that we've done in class that higher education people tend to earn more, but we can look at that in our data as well. Okay. So the next thing we're going to do is we're going to calculate the university wage premium for 1997. So basically, how much more does a university graduate expect to earn relative to a non-university graduate? So we're going to regress. Oh, sorry, we need to generate our log first. So we need to log wages because we like interpreting things in percentages. So generate a new variable. I just called it L, hour wage. You can call it whatever you want. Equals the log of the real wage. Okay. Take that. And then we're going to do this and regress that variable, a new variable log on unigrad and some other control variables. Okay. But we want to do this just for 1997. Oops, if year equal 1997. We do that. And look at that, we find, oh, look how big that return is, right? So 40%, almost 50% more. Okay. We did some talk about in class interpreting these and what these other variables might mean in terms of, does this mean sexism, does this mean racism, but I won't cover that here. So this suggests that university graduates earn more on average, at least in 1997. We saw that university graduate, the supply has increased over time, okay? And that the top wage earners have pulled away from middle wage earners. So we have lots of pieces of information here. The next thing we might want to figure out is, okay, well, what has happened then to university graduate, the return to university graduate education over time? So the thing that we might think is, given the supply, we would expect that to decrease. Given what we see here, that university graduates earn more, so they're the ones that are going to be near the top of the distribution, and actually people at the top of the distribution are now earning more than people in the middle of the distribution and the bottom, relatively speaking, over time. So we want to know, how has this coefficient changed over time? So to do that, we're going to generate an interaction term, right? If we want to allow an effect to vary depending on some other variable, we generate an interaction term, which is simply the product of 2 variables. So here we're going to generate a new variable called inter for interaction, which is equal to the product of year and unigrad. And then we are going to re-estimate our model now, not for every year, not for 1 year, but for every year. So we're not conditioning it here at the end. But same model, except now we're including a control for the year and the interaction term. Okay, so there we go. Now, how to interpret this? This gets a bit tricky. So a good way to do it, we did this in one of the classes, but a good way to do this is just write down on a piece of paper, write down y equals beta 1 times x plus beta 2 times year times x. Okay, just write that down on a piece of paper, and then take the first derivative of this little equation, take the first derivative of that with respect to x, and see what you're left with. Okay, so once you have that, so you have the derivative. Now that derivative is the change in y given a change in x. So if we look at our model, it's the change in the log wage given a change in unigrad. So you can see that first derivative is still going to be a function of year. In fact, what you're going to be left with is beta 1 plus beta 2 times year. So the effect of unigrad on log wages is going to depend on the year. As the year gets higher, that effect is going to get larger. If you want to work out the average effect, so on average, what is the effect of unigrad on wages, then you need to plug in the mean for year. So you put year bar here, right? The sample mean of year, which is about 2,000. You can do summarize and see that yourself. You plug that in, and you'd find that, on average, returns have been about, I think it's 0.52 it works out to. Okay? So we can't interpret this coefficient by itself. This doesn't mean unigrads earn 365% less than non-unigrad. We can't interpret that by itself, because the effect of unigrad depends on this coefficient and on this coefficient. And if you see that as you increase year, you increase the returns to education. So this is telling us returns to education have been increasing. So what does that tell us about using all of our sort of bits of evidence here together? What does this suggest? We've seen that more educated people earn more. we've seen that there's more educated people. The supply of more educated people has been increasing. So if the supply is increasing and the price, which is just the wage, and the price for those people is increasing, what does that tell us about what's going on with demand? Well, it says that demand must be increasing by even more than supply. That is, demand for university graduates has been increasing faster than the supply has been increasing, which is why we see hiring returns to education over time. The returns to education have increased with time. Right? And this is what leads people like Matthias and researchers working in this area to consider, okay, well, why is that? What has changed in the economy such that demand for highly educated workers has increased? And so they move into this whole question about technological change. As technologies change, it favors people that are highly educated. So you need more educated people to be using that technology to get the most out of it. All right? Now, going back to our question about the ratios, the 90-50 ratios, 50-10 ratios, we have all these data. We have lots and lots of data on people in each year, but we want to summarize those distributions for each year. So we could do it by hand, right? Summarize wage if year equals 1990, summarize wage if year equals 1991, then calculate by hand the 90-50 ratios. But that would take forever and would be really boring. So instead what we're going to use is this fancy command called collapse. Just copy and paste it from the worksheet. But what this does is it's going to create a new data set that is full of summary statistics in each year. Okay? So this is saying collapse our data, and Stata, I want the 90th percentile of the real wage, I want the 50th percentile, the median of real wage, I want the 10th percentile, I want the mean, and I want the mean of unigrad in each year. Okay? So if we just do that, we can then look at our data set and you see now we don't have thousands and thousands of observations. Now we have 23 observations, one observation for each year, and our variables are the 90th percentile of the wage distribution in 1990, the 50th percentile of the wage distribution in 1990, so on and so forth. Okay? And here you can see the proportion of people going to university. So it's increased from less than a quarter to more than a third in that 23-year period. So now what we can do is, rather than just looking at the 2 points in time, 1997 and 2012, we can look at trends over time. Okay? And that helps deal with some of the random sample variation from each year, year-to-year variation that's really just due to changes in the random sample that we've selected as random sample variation. So we can consider trends. So to do that, we're going to draw a line. Okay? So it's telling us saying, Stata, draw me a line that's, actually let's not do this one, let's just do the ratios. So first we need to generate the ratios. So this is tells us make the 90-50 ratio for each year. Make the 50-10 ratio for each year. And now we're telling Stata, draw me a line. So the last variable with this command is Stata, I have two variables, I need a two-way plot, so Cartesian coordinate system space. Draw me a line. I have this is going to be a y variable, this is going to be a y variable, and this is on the x-axis. So the last variable is the one on the x-axis. And this is what we get. So here we're plotting, the blue line is the 90-50 ratio. So the ratio of the 90th percentile of the wage distribution to the 50th percentile, and this is the 50-10. So you can see it's noisy, right? It bounces around from year to year, but there do seem to be trends that we can pick out. So the first one for the 90-50 ratio seems it trends up quite strongly. And that seems pretty consistent over time. It's trending up, meaning the top of the distribution is pulling away from the middle of the distribution. And down here we see that the 50-10, so the middle of the distribution and the bottom are actually getting closer together. Until sort of early 2000s, then it seems like it's flat, sort of flattens out down here. But it certainly seems that it's decreased over time. So this raises questions. When we say, well, inequality has gotten worse, the question becomes, well, what do you mean by inequality? What part of the distribution are you talking about? Because yes, top income earners are earning more, but the bottom of the income distribution is catching up with the middle. So is that good? Is that bad? Which part of the distribution do we care about? I mean, this is being driven by not by all of their wages getting worse, but by the 10% wages in the 10th percentile coming up. So if what you really care about is the poorest people, well, they seem to be doing, they seem to be getting better off relative to the middle. And the top is also getting better off, which maybe you also think is unfair, or you may think that it harms growth or affects, civic engagement, all sorts of things. But The question about inequality increasing or decreasing is much more complicated than, oh, the 1% are earning more income. There's a lot more going on. There's a lot more information in the distribution that we should consider before answering questions like that. Okay, so I hope that's helpful. I hope that's useful. Yeah, and good luck with revision. Good luck with the project, and I will see you all soon.